everybody, and welcome to Bolus videos. Today we're going to start our K series. This is going to be part 1. It's going to be potassium and homeostasis. That's going to be potassium in our bodies in its normal state, in complete equilibrium, in homeostasis in our bodies. There are some questions we're going to ask ourselves and we're going to answer, like, what is potassium? Where is potassium? And how much potassium is there in homeostasis? So, if we all remember our periodic table and we look back to this element we call potassium, we know that it has an atomic number of 19. So that means that it has 19 protons, 19 electrons, as well as 20 neutrons. Now what does that all add up to? That all adds up to this atomic number that I'll play into a little bit later. It's the actual weight of the molecule, which is depicted down here. But again, that'll come into play later. It's also an alkali metal from its group that it's in. But we don't see it as that. What do we see it as? We see it as a potassium ion. That means it has a charge. What kind of charge does it have? Well, it's a cation, so it has a positive charge. But how does it get that positive charge? It actually loses an electron. So if we all remember the electrons in the outer valence shell, one of them goes away, and that's what actually gives us this positive cation. It gives us this ion, and it's a free-floating ion in our body. So if we take our cell, and we have two big aspects of the cell. We have the intracellular and extracellular, both of which play in a large part of potassium. The main part is intracellular though, and we're going to show it like this. So we see this membrane right here. And this membrane has two sides as well, in and out, and it's that outer side of the outside of the cell. And we have this phospholipid bilayer and two parts of it. We have a hydrophilic side of it, and we also have a hydrophobic side of it. See, the hydrophilic side are actually these molecules right here that attract water, and the hydrophobic are the molecules that repel water. And then you can see right here we have our sodium-potassium pump. Notice that we have two cations, and it's a NAK-ATPase, and that's what is actually going to be used to move potassium in and out of the cell. So how much potassium is there? 98% of potassium is intracellular. That means it's inside the cell, and only 2% is outside the cell. That's why potassium is our main intracellular cation. It's our major intracellular cation. So if we could see here, we have a lot of potassium inside and a little bit outside. So these shifts that we have outside of homeostasis can be relatively dangerous. So that's why it's really important to remember that potassium is normally inside the cell, and when it becomes outside is when we start having some problems. So next time on our next Bolus video, what we're going to actually look into is potassium mechanism of action in homeostasis in our bodies. It's going to be a little bit longer, but it's going to tell us a lot about what we need to know about potassium and why it's so important. So feel free to contact me. I'm going to be at paramediccharlie@yahoo.com.